Hello friends, welcome to all of you again on your channel, that is JE Physics Maniac. So in this session, I'm going to discuss few of the most rarest questions. These are not extremely difficult, they are different questions and you will definitely enjoy in due course of the game. So without wasting much time, let us start. So you first pause the screen, read the question carefully, then try on your own. So the question is saying that there is a charge Q located at the tip of a hollow cone, mind it. So hollow cone in the sense the charge is only distributed over the surface. And the parameters are given. They are giving that the surface charge density is sigma, the slant height of the cone is L, half angle, the vertex is theta. What can you say about the force on the charge Q due to the cone? Now you see here. So here is the representative diagram that there is a charge Q that you can see. Here is the charge. So and now this hollow cone is basically a collection of number of elemental rings. So what I have taken an elemental ring over here. You can check on the diagram, for which I have taken that this elemental ring is at L slant distance away and this thickness here I am taking it to be dl. Everything is mentioned in the question. In the diagram you can see. So what I am taking that in that elemental ring, in the side I am taking, in the side here I am taking a small charge dq. So I am going to take the interaction between this q and this dq. This is my target. Alright. So the force, since both of them are positive charge, so the force will be repulsive and it will be in that direction. That is a df. So if I resolve df into two components, we will get this as x component and this as y component. All right, fine. So x component will become df sine theta as you can see here, and y component will become df cos theta as you can see here. Similarly, on the left side also I have taken one element symmetrically opposite. For this is the force, and this force will also have x component as well as y component and same value. So from these two, you can check that this df sine theta and this df sine theta, they are mutually opposite in direction, hence they will cancel each other. So for any number of pair, the horizontal forces will cancel each other. So which force will survive? This is this force that will survive, correct? So what I am taking that this force df cos theta. What is df cos theta? Df cos theta is basically, this is the force between small q and dq. What is a dq? dq is an element within the elemental ring. dq is not the charge on the ring. dq is an element on the elemental ring, right? Okay. So this df cos theta is coming to be, df is very simple. Formula is what? 1 by 4 pi epsilon naught q1 q2 by r square. R here is L, so I have written L square. Cos theta factor is surviving. All right, fine. Now let's go down. So now if I integrate over this, so my target is to get the total vertical force acting on the ring now for this elemental ring, correct? So total vertical force on the ring, rather I must write here on the elemental ring. That is that element that I have taken. How much force is acting out there? We can clearly check that if I integrate over this, every other thing remains constant. Integration over dq will give you q on the ring. So q ring is basically charge on the elemental ring. So here I will mention that this q ring factor, whatever you are seeing here, q ring is nothing but this is charge on the elemental ring. All right, this is clear to you. So this is the total vertical force acting on the elemental ring, correct? Now you see from this diagram, this I have taken to be L. If I take this radius of the elemental ring to be r, then from this right angle triangle that you are seeing over here, from there I can write r by L is basically equal to sine theta. So r will become how much? L sine theta. So I have written r equal to L sine theta. All right. Then area of the elemental ring. Area of the elemental ring is periphery into thickness. Come here. This is the periphery. Periphery is 2 pi into smaller. All right. Thickness is dl, that I have already considered. This length is dl. All right. So area is coming to be 2 pi r into dl. R is equal to L sine theta. We already got earlier. So I'm just substituting the value. So 2 pi L sine theta into dl. So this is the area that we are getting. Now, so charge on that elemental ring, Q ring, will be equal to surface charge density sigma into area of that elemental portion. All right, correct? Now what I am going to do, I am just simply going to substitute this result of Q ring here in this equation. So this is the equation 1 that I have considered. Previously I have calculated. So if I substitute the value out there, then after substitution of Q ring, I have to integrate. The integration is over dl, that is a slant length. If I take the total length to be capital L from here to here, this length if I take to be capital L, then the integration will be from 0 to capital L, and integrand is coming to be dl by L. So it's a very simple integration that you can do. So it is not of much headache. I hope you have understood. Right. So let us go for the second part of the question. What they are saying now, in the second part of the question, they are saying if the top half of the cone is removed and thrown away, what is the force on the charge Q due to the remaining part? So this half portion now they have removed. So I think I do not have any problem because I have already figured out the integrand factor, and the integrand factor was about dl. So if the integrand factor is about dl, what I will do, that this portion, half portion removed, this is L by 2 and this is L by 2. So from here to here, if I integrate, my integration will become from L by 2 to L. So that's precisely what I have done. This factor is a constant factor, so it is reciprocated as it is. Only this lower limit and upper limit is changed from L by 2 to L. I hope you have understood. This is simple, right? So this is a really intriguing question. Not difficult question, but it's a good question. Many other questions can be derived from this, which I will come on the next series, right? Okay. So let us go for the next question. It is another very interesting question. Very, very interesting question. What you can see, again read the question, pause the screen, try on your own. There are two strips of charge as shown in the figure. They have width B here, infinite height, negligible thickness. Their charge densities per unit area are plus minus sigma. This is plus sigma and this is minus sigma. Find the magnitude of electric field due to one of the strips at a distance x away from it. Very simple. So what I'm going to do, if I take any of the set and if I consider some patches like this, so since they are having negligible thickness, so these patches will behave like a rod. So they will behave like a rod, correct? So this is clear to you. So that's exactly what I'm taking in this figure, you see. So I have taken an elemental rod. I have taken a point P, which is at r distance away. From this face, it is at x distance. Thickness is B. So basically, I have to integrate from here to here. That I will come later. You see now. So for this, linear charge density is there. For this is behaving like a rod, elemental rod. So lambda is basically equal to surface charge density into dr. Correct? Since it is a long wire, infinite long set, so that is charge per unit length lambda will be equal to sigma charge per unit area into dr. You can check the dimension. You see here, this is charge per unit length. This is charge per unit area into length. So length and area cancel, charge per unit length, charge per unit length. Dimensionally it is valid, so there is no problem. So now what I'm going to do, I know what is the field at a distance r away from an infinite rod or infinite line charge. That is what? Lambda by 2 pi epsilon naught r. This is known to us, a known result. I'm just substituting this value of lambda here in this equation. Correct? So if I substitute the value of lambda in that equation, I will get immediately the integration factor. So how much I am getting here? That sigma dr by 2 pi epsilon naught into r. So E function of x at a distance x away, sigma by 2 pi epsilon naught is a constant factor out of the integration, and the integration will be from this portion to this portion, because this is the region, this shaded region is the region where charge is there. So this entire portion charge is there. So the limit will be from x to x plus b. I hope this is clear to all of you. So this beautiful result will come, that will be E function of x equal to sigma by 2 pi epsilon naught log of x by b by x. Now, I am going to make this situation more interesting. What I am going to do, now I am going to calculate what is the force acting in between these two strips per unit height or per unit length. So now that's going to be interesting. So force between two strips, within bracket I will write per unit height. Okay, since they are infinitely long, so I have to take per unit height. So for that, what I'm going to do, I'm just going to take the same diagram, but I'm going to take this length to be L. Let us restrict. Let us take a finite length and let's see what's happening. So considering the rod of finite length or finite height L, the force on the elemental ring will be equal to, force equal to what? We know F is equal to, we know Q into E. So I'm just applying the same formula for the elemental portion. So dq is the charge on that rod of length L into E function of X. So dq can be written as sigma dot dA into E function of X. What is a dA? dA is L dx into E function of X. Alright. So from there, you can check here, dF is equal to sigma L dx. Ex we already figure out. This is the value of Ex. So we'll substitute here. So after that, we will simply take integration, because now what will happen, see, we will have the force of interaction between them. That means we will consider that this will generate the field, and because of which this will feel the force. As we know from Newton's laws of motion, action and reaction cannot simultaneously be acting on the single system. So that's why the left one will create the field and the right one will feel the force due to it. So that's why I'm taking the limit from 0 to b. So after integration, I hope you are sophisticated enough mathematically to carry out this integration, simple integration. So the result will be F is equal to sigma square L by 2 pi epsilon naught 2b log of 2. Since they are asking what is the force per unit length, so I will just change this result. I will write force by L, and this will be the final answer. So F by L is equal to sigma square by 2 pi epsilon naught 2b into log of 2. Right? Okay. Very interesting case. Let us go for the next one quickly. Another very interesting. So they are saying there are two infinite planar sets of surface charge with densities 3 sigma naught and minus 2 sigma naught are located at a distance L apart, parallel to one another. Discuss the electric field of the system. Now you see here. So here I have divided three regions, as you can check, region 1, region 2 and region 3. These are the three regions that I have taken. All right. And the left side I have taken to be 3 sigma naught, right side I have taken to be minus 2 sigma naught. Well, here in this, you can see that on the left side, I have marked this charge with blue color, and field line due to this blue or 3 sigma naught is always represented as blue color. Now let us stick to 3 sigma naught first. We know that for positive charges, field is radially outward. What we know? For positive charges, field is radially outward. So for positive charge, field is radially outward. And for negative charge, field is radially inward. It's a simple thing. So if it is radially outward, in all region it will be radially outward. You check now, 3 sigma naught. In region 1, radially outward, radially outward, radially outward. I hope it is understandable. Correct? In all region due to 3 sigma naught, field is radially outward. If you check for minus 2 sigma naught, field is always radially inward. That means into the plane. It is always entering the plane. You see, always entering the plane. In all region, it is always entering the plane. Right? For 3 sigma naught, it was always originating from the plane and moving out from it. And for minus 2 sigma naught, it is always entering into the plane. So we know that field due to infinite seed is equal to sigma by 2 epsilon naught. This is known to us. So from there, I have calculated the field due to the left one and right one. So right one, due to this, I am tagging it as E1. So E1 is equal to, in place of sigma, I have to write 2 sigma naught. Why? Because the charge here is minus 2 sigma naught. All right, fine. And for E2, that is for 3 sigma naught, you check E2 is equal to, in place of sigma, I will write 3 sigma naught. All right. And remaining formula remains same. So E1 and E2 we have calculated. Then what about the field in these regions? You check here. Now I will calculate one by one. So for this region, see, this is E2. E2 is outward, E1 is inward. So here field will be equal to E2 minus E1. So E2 is how much? E2 is equal to 3 sigma naught by 2 epsilon naught minus sigma naught by epsilon naught. So it will become sigma naught by 2 epsilon naught, and the net field will be away from it. So in this region, this is the net field E3. In region 2, both are in same direction. You check E1, E2, both are in same direction. So field here will be E1 plus E2, that is 3 sigma naught by 2 epsilon naught plus sigma naught by epsilon naught. It will become 5 sigma naught by 2 epsilon naught, and this is the direction of the field. So this is E2, right? What about region 1? So here you can see that this field is in the rightward direction, this is in the leftward direction. So let us check that this field is basically 3 sigma naught by 2 epsilon naught minus sigma naught by epsilon naught. So this is coming sigma naught by 2 epsilon naught, and this field is in the left direction. All right, correct? This is in the left direction. This is E1. So if I have to give a representative diagram, then the diagram will look like, how much will it look like, and what will be the shape? Here it will look like, this is the plate 3 sigma naught, this is the plate minus 2 sigma naught. So I am writing this is plus 3 sigma naught, this is minus 2 sigma naught. So here we have the field in this direction. Here we have the field in this direction, that is of sigma naught by 2 epsilon naught. In between, field is in that direction. This is 5 sigma naught by 2 epsilon naught, and here the field is in that direction, that is of sigma naught by 2 epsilon naught. So that is going to be the net representation. All right, fine, correct. So let us come to the next case, which is a very interesting case. Instead of 2 now, I have 3 plates. Okay, before going into the next question, this I am leaving homework for you. So here the plates are parallel to each other. In the next case, they are saying if the plates intersect each other at right angle, then what will be the field? So that I am leaving as homework for you. Please let me know in the comment box. Now let us come to this question. And this is the last representation for all of us. So here instead of 2, we have 3 plates here, right? 3 infinite sheets are there intersecting at equal angles. So what is the net field that we have to check? Now here I have represented 3 plane sheets in different color. This is A, this is B, and this is C. See, for each plate, field is always perpendicular and radially away from it. Why? Because all of them are plus. So positive charge distribution is there. So let us check for A. For A first, see, this is perpendicular to this plane, correct? And it has 2 components, X component, Y component, right? That I have taken. Think about this C here. Similarly, it is perpendicular to this plane. It also has X component, Y component, correct? No problem, no harm in it. And then think about B. For B, since it is vertical, so field is in X direction, so that is EB, right? I hope it is quite understandable for all of you. If I want to calculate their value, since all of them are having the same magnitude, so EA is equal to EB is equal to EC, that is equal to sigma by 2 epsilon naught. This angle will be 45 degree, this will also be 45 degree, this is 45 degree, this is 45 degree. All right, you can check here that these are 2 fields. Basically, they are equal and opposite to each other, so they will cancel each other, right? So if they are cancelling each other, that means only the X component is surviving. So net field will be this, this, and this. So E net, it will be only along X axis. So it will be how much? Sigma by 2 epsilon naught, that is because of EB. And for these two, cos 45 degree means 1 by root 2. So for these two, I will write simultaneously 2 into sigma by 2 epsilon naught into cos 45 degree means 1 by root 2. So these two cancels. So it will be sigma by 2 epsilon naught plus of sigma by root 2 epsilon naught. That is E net X. But more than the value on the direction is important. So direction is coming to be along X axis. So now in that way, if I cover all the regions and sum up the values, then the electric field on a net will look like this. So for this region, it will be like horizontal. For this region, it will be like this. It will be like this. For this region, horizontal, same like the first region, and this is. So for every single pair, if we take these pairs, see here, fields are anti-parallel to each other. For these pair, fields are anti-parallel to each other. And for this pair also, fields are anti-parallel to each other. Correct? So I hope you have enjoyed. So that's why we say physics is always love to do. Correct? I hope you have enjoyed. Regarding the field, I have done one more video previously in Field the Physics series. If you want to check the video, I will give the link in the I button. Please check it. Thank you very much. If you like, please do subscribe and share. And let me know your feeling, what you are feeling about this and what kind of problems you want to check hence onwards. Do let me know in the comment box. Bye-bye.